Welcome back to the Cisco NetAcad CCNA3 Enterprise Networking, Security and Automation lecture series. If you haven't seen my previous lecture series covering CCNA1 and CCNA2, I will leave links in the description for those playlists. I would recommend that you go through the previous CCNA lectures before you move forward with this course. Today, I will cover module number 12, which is network troubleshooting. The primary objective of this module is to learn how we can troubleshoot enterprise networks. We will cover the network documentation, troubleshooting process, troubleshooting tools, symptoms and causes of network problems, the most common ones, and the troubleshooting IP connectivity. Network documentation. Documentation overview. Accurate and complete network documentation is required to effectively monitor and troubleshoot networks. The common network documentation include the following: the physical and logical network topology diagrams, the network device documentation that records all related device information, the network performance baseline documentation. All network documentation should be kept in a single location and backup documentation should be maintained and kept in a separate location. So if something happened, you have access to these documents because we have a backup of those documentation, and you also know exactly where to look for because it is in a single location when you need them. Network topology diagrams. So there are two types of network topology diagrams. They are the physical diagrams and logical diagrams. In my opinion, it is very important you have both, not just one, because sometimes what's really needed to get to your device is the physical topology, because you need to know where the device is located within your company's building or the floor. But you also need to know the logical topology because certain configurations have a huge impact on how the logical topology is built, right? OSPF, for example, like you need to know where those links are created and where the edge router is, and etc., right? So it is, in my opinion, it is very important you have both of these, not one of these. So not just one of them. You should have, in a properly designed network topology diagram documentations, you should have both physical and logical topology diagrams. And one more thing I want to point out is that, in my opinion, I have seen a lot of companies and a lot of organizations do have the physical topology, but often forget to include the logical topology, or the logical topology is incorrect because things have changed and they haven't updated it, because the physical topology is still correct. They just ignore one topology over the other for updating purposes. So these topologies has to be current, updated, and in my opinion, you should have both physical and logical in your documentation. Network device documentation. Network device documentation should contain accurate, up-to-date records of the network hardware and software, as I mentioned before. The documentation should include all related information about the network devices. So that it should include the network device documentation, switch device documentation, end system documentation, etc., in this example. And you should have the device interface information. What is that interface is connected to, the IP addresses associated with it, even the iOS or the firmware versions associated with it, and the licenses and the protocols being used. Like, for example, here we have OSPF version 3, etc., being used, and we even have the ports that are not in use clearly documented, saying they are being shut off, and how it is being managed as well. So I think This is very important in a properly run enterprise environment, that you have this kind of detailed documentation of those devices. Establish a network baseline. A network baseline is used to establish normal network performance to determine the personality of a network under normal conditions. What that basically means is we would like to know how would our network behave under normal usage, under certain conditions, right? So we want to know under daily usage, what will happen on our network. So that's what basically a network baseline is. So establishing a network performance baseline requires collecting performance data from the ports and devices that are essential to the network operation. The baseline data is as follows. It provides insight into whether the current network design can meet business requirements, and it can also provide us with information on areas of congestion or areas in the network that are underutilized. So when we will gonna create these type of network baselines, what you need to understand is that you can take the baseline during the high usage period or low usage period. You need to take the baseline either an average of those two, or during the periods of normal usage of your network, right? So keep that in mind. So if you take a network baseline during COVID-19 at your corporate office, where most of your users are working remotely through VPN, that baseline going to be completely different from a baseline that you would take on a situation where all of your workers are in person, and the baseline was taken during a peak hour, right? So keep that in mind. So when you're thinking about network baselines or any type of baseline, a performance baseline associated with servers, for example, with Windows enterprise servers, you need to take into account the human behavioral factors as well as the operation of your organization during the time of which the baseline is data being collected. The longer the periods that you take this network baseline data for creating certain statistics, is better, in my opinion, the baseline going to be. So keep those factors in mind when you're trying to create those baselines. So step one is to determine what types of data to collect, right? So when conducting the initial baseline, start by selecting a few variables that represent the defined policies. If too many data points are selected, the amount of data can be overwhelming, making analysis of the collected data difficult. So start out simply and fine tune along the way. So start out as a simple baseline and then keep adding some data points on top of that. Some good starting variables are the interface utilization and the CPU utilization. So those could be the starting point for your baseline. Step 2, identify devices and ports of interest. A logical network topology can be useful in identifying key devices and ports to monitor. As shown in the sample topology on the right hand side, right here, the devices and ports of interest includes the PC1 right here, which is the administration terminal, the two servers, which is the server 1 and server 2, they are located up here, and the router interfaces, which are these interfaces, and the key points on switches. So the key points would be these ether channel, for example, these 2 points, and that point, for example. Then you need to determine the baseline duration. So that's where I gave a quick speech at the beginning of these slides. When capturing data for analysis, the period specified should be at a minimum 7 days long. That's the recommendation by the Cisco. But I would say minimum a couple of weeks to a month even in certain situations, especially in enterprise large scale networks. I would say minimum more than 7 days long. Last no more than 6 weeks unless specific long-term trends needed to be measured, because things could change over a longer period. Generally a 2 to 4 weeks baseline is adequate. So I would recommend at least 2 weeks to 4 weeks baselines, at least 2 weeks baselines, not just 7 days, because again 7 days in my opinion is too short, but Cisco recommend at minimum 7 days long and maximum of around 4 weeks baselines would be good enough. So for exams and quizzes for Cisco, this is what is recommended. Conduct an annual analysis of the entire network or baseline different sections of the network on a rotating basis would also help you out with calibrating your baselines. Analysis must be conducted regularly to understand how the network is affected by growth and other changes within your network. As I mentioned before, when you are taking these baselines, you also need to take into consideration of your situation, current situation, right? Especially with COVID-19, you had to look at from that point of view whether all the workers are in person working or they are all working from remotely or partially remote. Part of your work group is working from home, part working from in person. That also have a huge impact on how your baseline data are going to be collected, right? So keep that in mind as well. Data measurements. The table lists some of the most common Cisco IOS commands used for data collection. On the right hand side, there's a list of commands that can be used on Cisco IOS devices and the description on the right hand side. For your Cisco lab exam especially, you should know these commands by heart. And for your lecture exams, these commands may show up. I have seen some of these exam questions do ask what these commands do. However, it is most likely to be a issue when you're writing lab exams, when you're taking lab exams, right? So just quickly go over the show version that will display the uptime, version information for device software and hardware, the show IP interface, or the option for the IPv6 right here. It would display all the configuration options that are set on an interface. The show interfaces, that would give you the detailed output for each interface. Show IP route and its IPv6 option will display the routing table content listing directly connected networks and the learn remote networks on your CLI or the terminal. The show CDP neighbors detail will display the detailed information about directly connected Cisco devices. Show ARP or ARP and show IPv6 neighbors would display the contents of the ARP table for IPv4 and the neighbor table for IPv6. And if you don't remember why IPv4 has an ARP table and IPv6 has a neighbor table, again, please go back to my YouTube channel and watch my previous lectures and lecture series such as CCNA1 and CCNA2 lecture series so that you have a better understanding of why IPv4 have an ARP table and why IPv6 have a neighbor table. And show running config will display current configurations of that Cisco device that you are interacting with. The show VLAN would display the status of the VLANs on the switch. Show port will show you the status of the ports on a switch. And show tech-support command is used to collect a large amount of information using multiple show commands for technical support reporting purposes. So for your understanding of how Cisco IOS commands work, you should know all of these commands and what they do so that you have a better understanding of how to navigate through your lab exams especially, but also might show up on your lecture exams. Troubleshooting process. General troubleshooting procedures. Troubleshooting can be time consuming because networks differ, problems differ, and troubleshooting experience varies. So using a structured troubleshooting method will shorten overall troubleshooting time, and there are several troubleshooting processes that can be used to solve a single problem. So the figure on the right hand side displays the logic flowchart of a simplified 3-stage troubleshooting process. So there are many other troubleshooting processes that you can follow. This is one of the many options available to you, even though it doesn't mention that here clearly. And in here, what happened is on the first stage, we're going to gather the symptoms. And the second stage, we're going to isolate the problem. And then we're going to implement corrective action. If that corrective action fix the problem, then you have to make sure you document the solution and save changes. One of the things that I see sometimes, people will fix the problem, network engineers and technicians will fix the problem, but they would never document that. So that is a bad practice, because that documentation will help the next technician or network engineer who may see the same problem to resolve the problem faster than what you have done here. So basically, after you gather the information, isolate the problem, implement the corrective action, and the action is working, you should always document the solution and save changes. And your organization should have proper procedures in place to do that. However, if that did not fix the problem, then what you need to do is that you need to undo the corrective action and start again, or you need to add to the corrective action. That wasn't described here. So if you implement a corrective action, but there are a couple of more steps you can take, you can simply add to that corrective action and see if that problem solves it. And if it doesn't, then you're gonna start all over again from the stage 1. So that's something that I would add to this flow chart, because sometimes you don't need to undo the entire corrective action. You just have to add something on top of that corrective action. 7-step troubleshooting process. So on the right hand side, this figure displays a more detailed 7-step troubleshooting process as opposed to the one that we just looking at it previously. So in here, we start at this part where we define the problem. So what we're going to do, we're going to verify that there is a problem and then properly define what exactly is the problem. So that shows that you have understanding of the exact problem that we are facing. Then we're going to gather information. So targets, example, the host and devices are identified, accessed, and information is gathered in that stage. We can analyze information that would identify possible causes using network documentation, network baselines, knowledge bases, and peers. Eliminate possible causes. In that stage, what's going to happen is progressively eliminate possible causes to eventually identify the most probable cause. Propose hypothesis. So just like any scientific process, you can propose a hypothesis. So when the most probable cause has been identified, a solution must be formulated, and that formulated solution would be the hypothesis. Then what we're going to do, we're going to test that hypothesis. So assess the urgency of the problem, create a rollback plan, and then implement the solution and verify outcome. You always need to make sure you have implement a rollback plan. You create a rollback plan before you implement the solution. Then you can implement the solution, because in case something goes wrong, you have that rollback plan to go back onto, right? Solve the problem. So when solve, inform all involved and document the cause and solution to help solve future problems. So that's where the documentation come into play, which I oftentimes don't see. So once the problem has been solved, you must inform all the parties in that network issue that was involved in that. And you also should document it clearly, so in the future, if the similar problem or same problem occurs, they have somewhere to start start from the beginning, right? So that is a good methodology. So on the top right hand side of your screen, you have this flow chart with arrows pointing at it. So let's look at it in a little bit on detail other than just the description. So you start with define the problem. Then you gather the information, and then you go and find a hypothesis based on that information. Now in here, you can analyze that information and hypothesis associated with that. or you can test the hypothesis right away, and you can then use this flowchart to solve the problem and document the solution. I would not just stick to these flow chart diagrams, so because you can jump anywhere in this flow chart in my opinion, but whatever you do, what really important is that you follow a proper step process, so you don't repeat stuff or you get convoluted in a convoluted situation. You get confused about what you are doing when you are trying to solve the problem. So that's the whole process, the whole purpose of having a proper troubleshooting process, right? Because that will eliminate the possibility of your repeating steps that no longer doesn't work, or you are getting into a convoluted situation and then you get confused about what you have done. So that's why it is important. So again, you don't have to follow these flow charts as it is. You just have to make sure whatever the steps you are taking, it is properly documented and you are following proper methodologies for trying to troubleshoot a problem, so you don't repeat and go in circles, right? So that's the whole purpose of troubleshooting process. Question end user. So the table provides questioning guidelines and sample open-ended end user questions. So as a network technician especially, and even sometimes as network engineers, you need to have some kind of a methodology in terms of trying to isolate problems. Like you have to have a methodology to isolate problems, especially when you are speaking to another human, especially not a computer and a human, because you are speaking to your end user. So you should always try to create open-ended questions as opposed to close-ended questions. I will give you some examples as we go through this slide. So ask related questions. So questions such as, what does not work? What exactly is the problem? What are you trying to accomplish? So these are good open-ended questions. A close-ended example of this would be, so you told me that the printer doesn't work. So as opposed to saying, what are you trying to accomplish? Don't say like things like, oh, so you told me the printer doesn't work. So because that gives the end user the idea that you believe as a network professional that the printer is broke. Maybe it's not the printer, maybe it's just the cable that going to the printer is broke. Printer is working fine. So don't ask questions like, so you told me that the printer doesn't work, or you told me that the printer is broke. Isn't the printer is broke? Don't ask that question. Instead, you ask, what are you trying to accomplish? So the end user may say something like, oh, I'm trying to print a document to our, using our network printer. Oh, so maybe it is a Wi-Fi issue. Maybe it is an Ethernet cable issue. So you can next ask associated question associated with that. Instead of saying, hey, you told me the printer is broken, you are asking the question, what are you trying to accomplish? See, open-ended. What are you trying to accomplish? Oh, I'm trying to print a document to our network printer. As opposed to saying, I'm trying to print a document to our USB connected printer. You know what I mean? So exactly. So make sure you ask the open-ended question. Determine the scope of the problem. So you can ask questions either to yourself or to the end user. Who does this issue affect? Is this you or other users? You can ask that question from the end user. You can ask yourself as a network engineer, hey, who does this problem actually going to affect, right? So what, and the other question, things like what device is this happening on? So you can ask your end user what device this is happening on. End user may give you an incorrect answer, but that's okay. But at least that shows where the problem is starting, right? Maybe a switch broke in between the network printer and the end user. There's a switch in the middle and the switch broke, and that's why it's not working. But to end user, it is the printer broken, right? So keep those in mind when you're asking these open-ended questions as well. Determine when the problem occurred or occurs. So ask questions like, when exactly does the problem occur? When was the problem first noticed? And were there any error messages displayed? So again, I'm going back to the example that I used, the printer. Some printers have LCD displays or screens that will display an error message, or their computer will have a pop-up on their Windows taskbar saying, hey, the printer is unable to reach the printer, or something like that, right? So those information is very important for you as a network technician or engineer, right? So when was the problem noticed? For example, let's say you have a company with 100 people trying to print to a single printer. Maybe there's a print queuing issue or the print server issue. So if everybody in the morning was able to print to that printer, but by evening or by midday, nobody can print to that printer, or only few people can access that printer, maybe there is a queuing buffer issue. See, that's why when was the problem first noticed, or what exactly does the problem, so when exactly that problem occurs may come into play. So this is a print example I'm still using, but it doesn't need to be a network printer. It could be anything else. It could be a router or a server that inaccessible, etc., etc. At the end of the day, these are all open-ended questions. Determine if the problem is constant or intermittent. Again, it goes back to when the problem occurs, right? You can ask the question from the end user, can you reproduce this problem? Can you send me a screenshot or video of the problem? Or can you describe the problem? So these are really good questions, open-ended questions you can ask from the end user. So sometimes you can reproduce the problem, like such as a network congestion or print queuing related issues. So that will give you an idea of where the issue is happening, right? Determine if anything has changed. So you can ask questions like, what has changed since the last time it did work? So this question can be asked both from your end user as well as your network technicians and network engineers and people who are managing your network or systems as well. So what has since changed since the last time, right? What has changed since the last time it did work? So that can apply to not only just the end users, but that question can be asked from people who are working in your environment as well, such as network engineers, because maybe you guys replace a switch you didn't know about. Maybe the department has replaced a server that you didn't know about that is causing this problem, or the printer is brand new and it wasn't there the day before. So that's why this question can also be asked from the end user as well. Use questions to eliminate or discover possible problems. So we can ask questions, open-ended questions like what works and what does not work. Like if the user say, oh, well, if I send 3 print requests in a row, only 1 get printed. But if I send 1 and wait for a couple of minutes and send the next print request, it both get printed. So the user is saying, hey, it doesn't work the way it's supposed to work, but however, I found a workaround to make it work somewhat. That also give you the the idea that maybe there's a print queuing issue or print server issue, not the printer, right? So that's an example. So I just use the network printer example here because I have a lot of experience troubleshooting that sort of problems. So this is something that you should keep in mind. One thing I want to point out here is that you do not have to be a network professional or systems professionals in order to ask these questions. I believe even management personnel as well as people who are in the front line who interact with the end users should also be familiar with these type of questioning methodologies, because in most jobs that you need to know how to ask right, proper, open-ended questions from end users in order to isolate a problem. Okay, so keep that in mind. So this is not just a good slide for network and IT professionals, but it is also a good slide for management personnel and others. Gather information. So common iOS commands can be used to gather network problem symptoms, and they are listed on the right hand side, and their description on the left hand they are listed on the left hand side and their description is listed on the right hand side. I have already gone through some of these examples on my previous lectures, so I'm going to quickly go over them right now. So remember ping, that will test the connectivity. and that is will give you the echo request. There was an ICMP packet. The trace route is a really good way to identify path a packet would take and a hop failure. So if there is a failure in a certain hop, the trace route command can figure that out. The telnet that connects IP address using the telnet application. However, it is recommended to use SSH over telnet to connect to devices because telnet is insecure. Show IP interface brief, the IPv6 version of it, show IP route, IPv6 version of it. All of these things would display some information about the interfaces as well as IPv6, IPv4 routing tables here. Show protocols will display the global and interface specific protocols configured on your Cisco device. Debug that would allow what's going to happen. The debug command is that the Cisco IO is going to display options for enabling and disabling debugging events, and you can pick whatever the choices you would like to make. So these are most of these items I have already covered previously on my previous lectures and videos, so you can go ahead and watch them if you want to know a in-depth analysis of those. Troubleshooting with layered models. So remember, I have introduced you to the OSI and TCP IP models on my previous lectures. So those models do come into play again whenever you are trying to troubleshoot things. And the figure on the right hand side shows some common devices and the OSI layers that must be examined during the troubleshooting process for that device. I'm going to do a separate video lecture on OSI model and post to my YouTube channel so you have a better understanding about OSI model. In my opinion, it is very important as network professionals and IT professionals that you understand this model. So you should know application, presentation, session, and you should know the transport network, data link, physical, etc., those layers and how they are differ from each other and what each of these layers do like back of your hand. By heart, you need to know exactly what the physical layer is, what the data link layer is, network layer is, transport layer is, session layer is, presentation layer is, and application layer is. Because if you don't understand this OSI model or the TCP IP model, which is not displayed on here, you will have a hard time troubleshooting your network. This is a fundamental concept that you should understand. So if you don't know how exactly OSI model work, or you are fussy about it, there is a video already, a lecture already posted on my YouTube channel. Please go back and watch it because it will help you out. And I will also post a secondary complementary video to my YouTube channel in the future on the OSI model and the TCP IP models, so that you will get a better comprehensive understanding of basic concept of networking. So if you don't understand the OSI model and the TCP IP model, well, you shouldn't be here now today. So keep that in mind. Structured troubleshooting methods. Different troubleshooting approaches that can be used to include the following. They include the bottom-up, top-down, divide and conquer, follow the path, substitution, comparison, and educated guess. I have used all of them for my home networking needs as well as my networking classes. I have used all of these items, not one or the other, honestly, in my opinion. So you shouldn't be sticking to one type of troubleshooting approach. In my opinion, you should mix them up. So let's look at what they are. So bottom up is a good approach to use when the problem is suspected to be a physical layer one. So you're going to start from the physical layer, the bottom of the stack, the physical layer of the OSI model. So we're going to start from bottom up and keep going up. So you're going to check the physical layer and see if all the physical network links, such as the wired cables, are not broken, your fiber optic line is not bent too much so that it's not broken, things like that. Then you move on to data link, then you move on to network, transport, and so on, by eliminating each one of them. So that's called the bottom up process. Top down, use this approach for simpler problems or when you think the problem is with a piece of software. So the top-down approach is basically, we, instead of going from the physical layer, we basically going from the application layer way up here and the user. So what not mentioned here is a user itself. So you can ask questions from the user. Hey, what's going on? Maybe user is doing something wrong. Maybe user is entering a value or something on a software that they shouldn't be entering. So that's a top-down approach. This is being used a lot, especially when you're trying to troubleshoot a problem and you believe everything is working fine for other users, and this one single user is complaining about a problem. The top-down approach is always almost the one to go for, because it's only one user out of 100 complaining about something. Probably top-down approach is the best option. Divide and conquer. Start at a middle layer, such as layer 3, and test in both directions from that layer. So you don't start on the bottom of that stack or the top of that stack. You don't start here, you don't start here. You start somewhere else, something like transport or a session or network layer, and then go from to the either side. So if, let's say, if it is network layer, you could check the transport layer and data link layer from the network layer's point of view. Follow the path. This is used to discover the actual traffic path from source to the destination to reduce the scope of troubleshooting. So you can check, okay, the user is trying to reach the server on the other end. So you're going to follow the path at which the user will be sending packets to and from source and destination, right? So that's the follow the path, and see if there's anything wrong along that path. Substitution. You physically swap out a suspected problematic device with a known working one. So if you have a enterprise network with multiple switches and routers between the source and the destination, you can change those devices with a known working device to see if those are the causes of the problem. So that is the substitution approach to this. This is probably not utilized a lot in terms of troubleshooting approach, because in enterprise network environment, you don't want to be in a situation where you keep swapping devices until you find the error. But it is a option that can be used too, especially with devices such as switches and routers and servers, where you have blinking lights, basically LED lights, just like a Christmas tree, that's showing what's the state of that device. So substitution can be used where the device has failed, or a port or multiple ports have failed, where you can swap out that problematic device with a known working device. So sometimes in that situation, I just go to a network closet and look at the lights. Why not? It's there for troubleshooting, right? For example, Cisco devices, D-Link devices, HP devices, IBM devices, as well as many other device manufacturers have certain blinking lights that will tell you certain things. Like, for example, with D-Link and I believe even Cisco devices, if the light is blinking green, that is at gigabit level. But if the light is blinking orange or amber, that is actually running at a reduced speeds. Like maybe there's a bottleneck, something happened in the network, or the port is configured to run at 10 megabyte to 100 megabyte per second. So it is not reaching the gigabyte capabilities. Just looking at the physical switch, you can see it is blinking orange. Right? And then I see in IBM switches where if a port is misbehaving, that means the port sometimes at 100 gigabyte, sometimes it is dropping to going up to 1000, and it's actually not behaving it's supposed to, or something happening in that port that is causing network congestion. It will blink red. There would be a red LED. So that's an example of, just look at it. With servers, some servers such as the HP servers, there are some indicator lights at the front of the servers, indicating hard drive failures. So you don't even need to go to the server configuration and see if the hard drive is failed, but just looking at it, you know that a RAID array hard drive has failed by just looking at the blinking lights on that device, right? So etc. So that's where the substitution come into play. It's very useful. Comparison. So in that situation, we attempt to resolve the problem by comparing non-operational element with a working one. So if you have two Cisco switches and one switch is working perfectly fine, you're just going to compare the two switches, not only blinking lights and physical stuff, but also configurations. Go into the configuration of each of these switches, the working one and the not working one, and see what are the differences between the two configuration. Finally, the educated guess. So success of this method varies based on your troubleshooting experience and your ability, but also your experience in that particular network. So if you work for a company for, let's say, 10 years, and most of the components within your network in that 10-year period, and you are well experienced in the topology, network design, and how it is implemented in that organization, you probably can make a very good educated guess without going through any of these troubleshooting processes. You don't have to do top down, bottom up, or divide and conquer, nothing. You can probably make an educated guess because you are experienced IT technician, right? So especially when you are working for a company for a long time, that is a very good useful tool. I do that even my current job. I'm not in a hands-on IT position right now, but I still use the educated guess to troubleshoot VoIP issues, for example, in my end users, right? So that's a good way to save some time. Guidelines for selecting a troubleshooting method. To quickly solve network problems, take the time to select the most effective and efficient network troubleshooting method. So the figure on the right hand side illustrates which method could be used when a certain type of problem is discovered. The troubleshooting is a skill that is developed by doing it. So over the period of your networking career, as you get more experience and you become more and more good at troubleshooting, every network problem you identify and solve gets added to your skill set. So every single time you solve a problem of a system or a network, you get good at it, and it get added to your repository of all your skill sets of troubleshooting, and you get better at it over a period of time. So on the right hand side, the diagram, if you look at it, here you have defining the problem, the type of problem, and the troubleshooting method listed, and you can determine the type of problem, analyze the symptoms, and apply previous experience. Or you can determine the type of problem and go to the top-down method or bottom-down method, for example. Or you can go to applying previous experiences. Again, you can divide and conquer method in that situation, or you can go to the bottom-up method. Notice, to use the divide and conquer method, the experience is needed, because otherwise you might spend hours and hours taking out items and try to troubleshoot the problem, as opposed to making that educated experience guess that would narrow down what needed to be divide and conquer, right? So keep that in mind. Troubleshooting process. Software troubleshooting tools. So there are some common software troubleshooting tools that you can use in your career. They include the network management system tools. Those are network software that includes device level monitoring, configuration, and fault management tools. Tools that can be used to investigate and collect network problems. Knowledge bases, also known as KBs. Those are online network device vendor knowledge bases that have become very important sources of information. When vendor-based knowledge bases are combined with internet search engines such as Google, a network administrator has access to a vast pool of experience-based information. So this also includes the online communities. So there's Microsoft online community of technicians. There is Cisco, CCNA, CCNP communities. They include official communities as well, where you can ask a question and people would help you out, including Cisco engineers themselves. Or it could be unofficial communities such as a Discord server, for example, right? So you can not, the knowledge bases are not only official documentation knowledge bases created by the companies like Cisco, IBM, and Microsoft, but also it could be a Discord server with a whole bunch of knowledge base information. And in addition to that, you may have your internal company documentations. So I work for a large organization and I have access to internal documentations on how to troubleshoot a problem that is basically a knowledge base not available to the outside of the organization, and we use it to troubleshoot all sorts of stuff and fix items. So when it's not only just vendor specific knowledge bases, but it also online communities and internal knowledge bases within your organization can be used for troubleshooting. Baselining tools. So many tools for automating the network documentation and baselining process are available. Baselining tools help with common documentation tasks such as network diagrams, update network software and hardware documentation, and cost effectively measure baseline network bandwidth use. So for example, the Windows Enterprise Server already comes with baselining tools that you can install on it. It can actually do even network baselining, some of the tools, but there are also third-party companies that provide baselining software and tools, as well as Cisco themselves within their Cisco architecture. Protocol analyzers. A protocol analyzer can capture and display the physical layer to the application layer information contained within a packet. Protocol analyzers such as Wireshark can help troubleshoot network performance problems. So if you have ever used Wireshark before, you are familiar with this type of analyzer. So what the Wireshark is doing is it is capturing those packets and analyzing those packets and displaying some information. So these protocol analyzers sometimes can be used to troubleshoot your network as well. I will do a Wireshark demonstration on a separate video, and I will show you how you can use it to figure out certain features when you're doing things like OSPF and other protocols. Hardware troubleshooting tools. There are multiple types of hardware troubleshooting tools available in the market, and some of them are listed here, but this is not an exhaustive list. This is just a handful of hardware tools. They include digital multimeters, which are devices that measure electrical values of voltage, current, and resistance. Cable testers. Those are handheld devices that are designed for testing the various type of data communication cabling. So such as Cat5e, Cat5, Cat6 cables. Also, you have these fiber optics cable testers. You can use it to test the continuity and proper termination. Cable analyzers. Those are multifunctional handheld devices used to test and certify copper and fiber cables. Portable network analyzers. Those are specialized devices. Those devices used for troubleshooting switched networks and VLANs. So there are these handheld devices also, as well as these small computers, even laptop software that you can plug into a network or a switch that will be able to analyze the network packets and network configurations as well as VLANs. Cisco Prime NAM or Cisco Prime NAM. That is a web-based interface that displays device performance analysis in a switch and routed environment. And this is a Cisco proprietary hardware tool that can be used. One of the other things that is not listed here for hardware also monitoring and troubleshooting tools is that things like cloud-based systems, Cisco Meraki, for example, would have its own set of toolkits that you can use to identify hardware issues associated with those cloud-based devices. Syslog server as a troubleshooting tool. So you can use the Syslog server as a method of troubleshooting because it is, after all, a system logs, right? So Syslog clients use the syslogs to send text-based log messages to the syslog server. So hence the syslog server would have all that information. So the log messages can be sent to the console, VTY lines, memory buffers, or syslog server. On Cisco iOS, log messages fall into one of 8 levels, and those levels are listed on the right hand side right here. And on my previous lecture, I mentioned that the lower the level number, the higher the severity going to be, right? So for example, an emergency is going to have 0, alert's going to be 1, and the basic debugging and informational message is going to have 6 and 7. So the lower the level, the more important that message going to be. So by default, the console display level 6 debugging messages. So right out of the box, all Cisco iOS devices would display the level 6 informational messages, nothing else. In the command output, the level 0, which are emergencies, all the way to 5, which are notifications, so 0, 1, 2, 3, 4, 5, are sent to the syslog server located at 209.165.200.225. How we know that? Because when we actually look at this particular example, in this example image, it shows that's where the logging going to happen. So this is just a particular example, even though they don't mention that here. So this is a command output right here, and the logging, when you issue the logging host and with the IP address, by default, what the Cisco gonna do, Cisco iOS, all the messages from 0 to 5 will be directly sent to the syslog server and would not be saved on the buffer itself. Otherwise, it would be in the Cisco device buffer, and you can view them by changing configuration on the Cisco iOS. Symptoms and causes of network problems. Physical layer troubleshooting. The table lists common symptoms of physical layer network problems. So on the bottom of your screen, these are some common physical layer issues that you might run into. For example, a symptom of performance lower than baseline requires various baselines for comparison. The most common reasons include overloaded or underpowered servers, unsuitable switch or router configuration, traffic congestion on a low capacity link, and chronic frame loss. Loss of connectivity. That could be caused by loss of connectivity, could be due to failed or disconnected cable, can be verified using a simple ping test. Intermittent connectivity loss can indicate a loose or oxidized connection. So if you have the connection end oxidized, the pins may not be properly plugging into the device, right? Network bottlenecks or congestion. So those happen if the route fails. Routing protocols could redirect traffic to suboptimal routes. As a result, this can create congestion or bottlenecks in the part of the network. High CPU utilization rates. High CPU utilization rates indicates that the device is operating at or exceeding its design limits. So if not addressed quickly, the CPU overloading can cause a device to shut down or fail, or it could even keep rebooting once in a while. So high CPU utilization could cause Cisco devices and IBM and many other devices to keep rebooting once in a while. That could happen. Console error messages. So the error messages reported on the device console could indicate a physical layer problem. So the console messages could be logged into a central syslog server so that you can analyze it. One note that is not listed here, the performance lower than baseline could also maybe caused by a mismatch of your network configurations. So the one side is duplexing, the other side is not duplex set. That could also cause the lowering of the performance as well. Power related issues. So in that situation, check the operation of the fans and ensure that the chassis intake and exhaust vents are cleared. So if you have random reboots, again, another reason could be that there is either a power related issue caused by the fans being blocked, or your power supply unit may have some kind of fault issues. Hardware faults, which brings to that it is a faulty or corrupted network interface card driver files, bad cabling or grounding problems can cause network transmission errors such as late collision, short frames, and jabber. So those are all and examples of corrupt network cards have driver failures, as well as hardware faults could also include power supply unit going out as well. Cabling faults, so look for damaged cables, improper cables, and poorly crimped connectors. That is a very common problem in large enterprise infrastructure. Sometimes even your best effort to make a very good crimped connector doesn't properly do its job. So make sure that when you are terminating those Cat5e, Cat6 cables or terminating those fiber optics lines, you are properly terminating them according to the standards. Suspect cables should be tested or exchanged with a known functioning cable. So that's the best solution for that. Attenuation, so signal attenuation can be caused if a cable length exceeds the design limit for the media, or when there is a poor connection resulting from a loose cable or dirty oxidized contacts. So those all contribute to signal attenuation. So cabling faults can cause signal attenuation. So the one just above it, the cabling faults, like the crimping issues, can also cause signal attenuation, but it also could be caused by other issues such as exceeding the length. So for example, if you have a access point located just beyond the maximum length a Cat5e cable can handle, that access point may work once in a while, and when that access point might work most of the time but may go out of service once in a while. That because of cable length may be the problem, right? So because that's a common issue that we have seen in the industry. So the cable length is too long, that could cause us issue where the system might work one day, the system doesn't work the next day, system might work in the morning but not in the evening, etc., etc. So that's an example of a cable length exceed. So that because of it is creating signal attenuation as a result. The cable is not designed to run that long, hence when it exceeds the design length for operations, it's going to result in significant signal attenuation. Noise, which is local electromagnetic interference, EMI, can be generated by many sources such as crosstalk, nearby electric cables, large electric motors, FM radio station, police radio stations, etc., etc. So those are noise. So even some microwaves at those cafeterias can create enough noise to interfere with your Wi-Fi networks, Wi-Fi infrastructure, for example. So be careful with the noise. And when it's come to point electromagnetic interference, it is never recommended to put network infrastructure cables along with electrical cables. So if you have like a ceiling with a channel with a lot of electrical cables going, you should have a separate channel for the network infrastructure. You shouldn't put your Cat5e, Cat6 and those type of cables with the electrical cables, because that will definitely create electromagnetic interference most likely. So not so much with the fiber optics, but everything else, yeah, you need to make sure that you separate those ones. But also if you put too many or certain types of Cat5e, Cat6 cables together in a bundle, and then you tighten them up or you make a loops out of those, sometimes because you have a long cable that have some extra length and you decided to create a loop, right, just to keep it tight, that loop can create an electromagnetic field causing noise. So be careful with like creating loops, because I have seen in pictures of those data centers and network classes, some people have created huge loops of Cat5e and Cat6 cables, and that is sometimes pretty bad for noise. So be careful with that. Interface configuration errors. So those are caused by incorrect clock rate, incorrect clock source, and interface not being turned on. This causes a loss of connectivity and with the attached network segments. Exceeding design limits. So a component could operate suboptimally if it is being utilized beyond its specifications. So imagine you have a 24 port Cisco switch, and it can handle gigabit data, but it is not an enterprise switch. It is a small business switch, but it is being installed in an enterprise environment with lots of people, lots of data going through in a day. That could actually exceed the design limits, causing the CPU and the RAM to downclock the device. So that brings into the next item, the CPU overload. Symptoms include processors with high CPU utilization percentages, input queues drop, slow performance, SNMP timeouts, no remote access, no DSCP services, telnet issues, and pings are slow or fail to respond. So those are indications of CPU overload. Again, that may be caused by because you have installed a device that should not have been installed in that particular location of your network, because it exceed that it's their design limit. So that could cause also CPU overload. The other ones, let's look at the data link layer troubleshooting. So here are some data link layer troubleshooting items listed in here. They include no functionality or connectivity at the network layer or above. So that's mean the data link have failed. So some layer 2 problems can stop the exchange of frames across a link, while others only cause the network performance to degrade. The network is operating below baseline performance levels will also may indicate in the data link layer issue. Frames can take a suboptimal path to their destination but still arriving, causing the network to experience unexpected high bandwidth usage on links. An extended or continuous ping can help figure out what's happening with those frames and where it's been dropped. And you can also use the trace route as well. Imagine you have a VoIP system, right? So the data may be going through, but it's not good enough for the VoIP to handle. So that is operating below the baseline performance, because remember, VoIP is time sensitive, right? Excessive broadcast. So operating systems use broadcast and multicast extensively. So it's like too excessive. It's just used way too much. And generally, those excessive broadcasts are the result of a poorly programmed or configured applications. So a large layer 2 broadcast domains is another reason, or an underlying network problem. So the excessive broadcast could be caused by all of those things, because of poorly programming of your Cisco and other devices, large layer 2 broadcast domains, or underlying network problems. That's something that you need to take into consideration. Console messages. So routers sends messages when it detects problems with interpreting incoming frames, basically encapsulation or framing problems, or when keep alives are expected but do not arrive. So the most common console messages that indicates a layer 2 problem is a line protocol down message. So that's the most common one, the line protocol down message. And another errors include the encapsulation errors, which is also happening in the data link layer. That occurs when the bits placed in a field by the sender are not what the receiver expect to see. So that means there is a problem with the encapsulation. Address mapping errors, which occurs when the layer 2 and layer addressing is not available. Framing errors. Framing errors can be caused by a noisy serial line, an improperly designed cable, faulty network interface card, duplex mismatch. Remember the slowdown of the network I previously mentioned can also be caused by a duplex mismatch or an incorrectly configured channel service unit, also known as CSU line clock. STP failures or loops. Those are caused by most likely because of STP problems are related to forwarding loops that occurred when no port in a redundant topology are blocked and the traffic is forwarded in circles indefinitely, excessively flooding, causing of a high rate of STP topology changes. So that is another issue that could happen in the data link or data link layer. Network layer troubleshooting. So here are some network layer issues listed right here. They include network failure. So occurs when the network is nearly or completely non-functional, affecting all users and applications on the network. These failures are usually noticed quickly by users and the network administrators, and obviously, critical to the productivity of the company. So when the network failure happen, your users will complain. So that's a nice thing about network failure. You would know right away there is a failure. Suboptimal performance. This involves a subset of users, applications, destinations, or type of traffic, and optimization issues can be difficult to detect and even harder to isolate and diagnose. So this is because they usually involve multiple layers or even a single host computer. So determining that the problem is a network layer problem can take time when there is a performance issue. As you've seen on my previous few slides, I have mentioned all of these slides that all of these things could cause performance issues, that physical layer issues, data link layer issues. So to figure out the suboptimal performance is a network layer issue might take some time to figure out. Another few items that network layer could have is a general network issues. So often a change in the topology may unknowingly have effects on other areas of the network. Determining whether anything in the network has recently changed, and if there is something that has changed or currently anyone is working on the network infrastructure, you should know about those things so that you can troubleshoot it. So that could be something simple like if I go back to that printer thing, if somebody changed a switch or a router, for example, between the printer and the user and forgot to configure some items in there, that might be the reason why you can't reach the printer, right? Network printer. So that's an example of that. Connectivity issues. So check for any equipment and connectivity problems, including power problems, environmental problems, and layer 1 problems such as cabling problems, bad ports, and ISP problems. So when they say environmental problems, let's say I seen situations where people put an access point outside the building, which is okay. There are access points that can do that. But in Canada, for example, where we have temperatures reaching up to minus 30 to 40 degrees Celsius, you need to make sure that whatever the outside access point that you are mounting is capable of handling, operating in that temperature, right? So that's an example of environmental problem, right? Another environmental problem could be dust. So you could have a Cisco switch in a very dusty environment that is not built to work on those dusty environments. Those are not rugged switches maybe. You got to have an enterprise switch that is built to go on a data center, but you decided to put it in a sawmill or something. So that's an environmental problem. So those are issues that could cause connectivity issue as well. Routing table. So you should check the routing table for any unexpected, such as missing routes or unexpected routes, because that will tell you where to troubleshoot. That will give you some starting points sometimes. Routing table not always necessarily going to give you this is the problem, this is the solution type of thing, but at least it will point you in the direction to figure out for a solution, figuring out a solution, right? Neighbor issues. So again, to check and see if there are any problems with the routing errors forming neighbor adjacencies, especially with the OSPF and other protocols. Topology database. So check the table for anything unexpected, such as missing entries or unexpected entries, again, such as like OSPF, etc., etc. Transport layer troubleshooting. Well, the transport layer troubleshooting have multiple aspects. So in this slide, we're going to focus on ACL, or access control list. So the table here lists areas where access control list misconfigurations commonly occurs. So I have gone over how we can do access control list in my previous lectures, previous modules. So if you don't know exactly how access control lists work, please go back to my YouTube channel and check those lectures so that you have a better idea. Today, we are just doing high-level overviews, right? So just keep that in mind. Every single time you hear terms like access control list, OSPF, things like that, they are available on my YouTube channel. Just go and watch it. So let's look at some misconfigurations. So selecting of traffic flow. So an ACL must be applied to the correct interface in the correct traffic direction. So if you get the direction wrong, or if you get the interface wrong, that could cause issues. Order of access control entries. Remember, in my lecture on access control lists, I have mentioned multiple times the entries in an access control list should be from specific to general. So it has to go from a specific entries to general entries. So access control lists always go from top to bottom. Remember, I have mentioned that multiple times. So the order of access control entries, or mixing the order that shouldn't have mixed, could cause problems. Implicit deny any. So the implicit access control entry can be the cause of an ACL misconfiguration. So remember, ACL already have the implicit ACE deny entry in there. So you need to take that into consideration. Addresses and IPv4 wildcard mask. So complex IPv4 wildcard masks are more efficient, but are more subject to configuration errors. Because remember, wildcard masks are things that you have to manually enter into your access control list ACE, right? The access control entry. So when you are entering them, make sure you do it right, especially if you have a lot of ACE entries, access control list entries in your ACL, right? It's easy to mix them, or enter it the wrong wildcard mask or something like that. Cisco iOS typically would tell you if your wildcard mask is wrong, but not always, because there are situations, sometimes certain situations, some IPs and stuff overlap and stuff like that. So be careful with that. Selection of transport layer protocol. So it is important that only the correct transport layer protocol be specified in the access control entry, so ACE entry. Source and destination ports, again, ensuring that the correct inbound and outbound ports are specified in the access control list is very important. Use of the established keywords. So remember, again, I have covered this on my previous lecture. The established keyword applied incorrectly can provide unexpected result, right? So I'm not going to go over what established keyword going to do in your ACL. If you don't remember what established keyword does, please go back to my YouTube and check my ACL lecture on why that keyword is important and what it does. But if you use it, what you need to understand, if you use it in a wrong place, it could create problems for you. Uncommon protocols. So misconfigured ACLs often cause problems for protocols other than TCP and UDP. So if you're using a very any uncommon protocols other than the TCP and UDP, that could create some misconfigurations on the ACLs as well. So the next item we're going to look at for the transport layer troubleshooting would be the NAT for IPv4, or network address translation for IPv4. So the table here again lists some common interoperability areas with NAT. They include things like BOOTP or boot P and DSCP. So the DSCP request packets has a source IPv4 address of COD 0. However, NAT requires both a valid destination and source IPv4 address, and therefore boot P and DSCP can have difficulty operating over a router running either static or dynamic NAT. So you need configuring the IPv4 helper feature in this situation can help solve this issue. So if you forgot to configure the IPv4 helper feature, that could result in this issue. DNS. So a DNS server outside the NAT router does not have an accurate representation of the network inside the router, right? So outside the NAT, if you have a DNS located outside the NAT, it doesn't know what's inside the NAT, right? So configuring the IPv4 helper feature again can help solve this problem. SNMP. So an SNMP management section on one side of the NAT router may not be able to contact the SNMP agents on the other side of the NAT router, because NAT is basically separating those sites, right? So configuring the IPv4 helper feature can help solve this problem as well. Basically, IPv4 helper feature is acting like a middleman to connect those two sites in a NAT situation. So as you can see, it's all IPv4 helper in these ones, right? So finally, the tunneling and encryption protocols. So encryption and tunneling protocols often requires that traffic be sourced from a specific UDP and TCP port, or use a protocol at the transport layer that cannot be processed by NAT. So that could actually cause a problem for you as well. Again, if you don't know much about NAT for IPv4, I have already done a comprehensive lecture on NAT for IPv4 and I have posted that to my YouTube channel. So please go back and watch those modules so that you have a better comprehensive idea about what we are talking about here. Application layer troubleshooting. The table provides a short description of these application layer protocols. These are some common protocols we use in the application layer. They include SSH and Telnet. Those enable users to establish terminal session connections with remote host. And remember, we recommend that you use SSH over Telnet for security reasons whenever it is possible. HTTP. That supports the exchanging of text, graphic images, sound, video, and other multimedia files on the World Wide Web or web in general. FTP, which is a file transfer protocol, performs interactive file transfers between hosts. TFTP performs basic interactive file transfers typically between hosts and networking devices. So TFTP may be used to back up your Cisco iOS images or sometimes syslog messages, for example. SMTP, that supports basic message delivery services used by emails. POP, which connects a mail servers and downloads email, again used in emails. SNMP, that it collects management information from network devices. I have already covered that topic. DNS, which maps IP addresses to names assigned to network devices. NFS, which is the network file system, enables computers to mount and use drives on remote hosts. So I will have a separate video on NFS and how you can configure it on my server lectures in the future. That is a protocol, an application that running on the application layer that allow you to have like a remote host acting like, for example, storage devices for your server. Troubleshooting IP connectivity. Components of troubleshooting end-to-end connectivity. So the bottom-up approach steps when there is no end-to-end connectivity is listed on this page right now. So the first thing we're going to do is to check physical connectivity at the point where the network communication stops. Next, we're going to check for duplex mismatches. Next, check data link and network layer addressing on the local network. Verify that the default gateway is correct. Ensure that devices are determining the correct path from the source to the destination. Verify the transport layer is functioning properly. Verify that there are no ACLs blocking the traffic, and then ensure that the DNS settings are correct. So that is the best bottom-up approach steps to take when there is no end-to-end connectivity. End-to-end connectivity problems initiates troubleshooting. Usually what initiates a troubleshooting effort is the discovery that there is a problem with end-to-end connectivity. Two of the most common utilities used to verify a problem with end-to-end connectivity are ping and traceroute. I have mentioned ping and traceroute multiple times, even in my previous lectures as well as previous slides. That is the easiest way to actually test your end-to-end connectivity. So if you ping from this device to this right here, this device, the ping should go through unless it is blocked by a ACL or there is a connectivity issue, right? And this device also should be able to ping all the way to here. So if the ping from here to here fail, then you can start pinging these ports, these gateways, and then see if this PC can reach. So maybe this PC can reach all the way up here, but all the way here, but not here. But here they can reach all the way to here, but not beyond that, etc. So ping can do that. Traceroute also can show you, the hop count as well as where the failure happened in this hop. So for example, hop 1, hop 2, hop 3, and the traceroute will say, okay, it fails right here. So that's why ping and traceroute can be used for connectivity testing. So that's the basic overview. So let's look at some of the steps associated with that. So verify the physical layer. So the show interfaces command is useful when troubleshooting performance related issues and hardware is suspected to be at fault. So of the interest in the output on the right hand side here are the interface status, our input queue drops, output queue drops, input errors and output errors. So on the right hand side we have run the show interface command. So we're going to use show interfaces command, and we're going to give the interface that we're going to look at, and in this case the gigabit 001, and it shows the input queue, output queue, any input errors and output errors. If there are errors, it should show up here, and then some information about the input queue and the output queue shown up here. Step 2, we're going to check for duplex mismatches, which is very common issue sometimes happens when different network technicians and engineers work on the same network. There may be some duplex mismatches. Nowadays everything should be full duplex, but for whatever reason a technician or an engineer may put something into half duplex by mistake. So the IEEE 802.3ab gigabit Ethernet standard mandates the use of auto negotiation for speed and duplex, and practically all fast Ethernet network interface cards also use auto negotiation by default. Problems occurred when there is a duplex mismatch. That happens typically because of now we have that IEEE 802.3ab gigabit Ethernet standard. When network technicians and engineers go into these net switches and routers and start changing stuff. So typically it is in auto negotiation no matter what. So even if one side is half duplex, the other side is full duplex, they will negotiate automatically with each other and decide whether they're going to be full duplex or half duplex. Or most of the devices nowadays going to be full duplex. Typically the problems what I see is happening is you go and change something on the router or the switch or something like that. That is what causing the problem. So keep that in mind. So to check that out, what you're going to do is you're going to run the show interface command again, and we're going to check whether it's in full duplex or half duplex. So if the one side is full duplex, the other side is half duplex, that's gonna create a problem, and you can fix it by putting both of them onto full duplex. Step 3, verify addressing on the local network. So the ARP command on Windows machines can display and modify the entries in the ARP cache that are used to store IPv4 addresses and their resolved Ethernet physical addresses. So if you run the ARP-A command, for example, it will list all the internet addresses, associated MAC addresses, and the type for it, such as dynamic or static, on your Windows machine. So that can verify the addressing on your local network because that's your ARP table. Troubleshoot VLAN assignment example. So another issue to consider when troubleshooting end-to-end connectivity is the VLAN assignment. Because remember, VLANs are virtual local area networks, so it's a virtual LAN. So you have to configure it properly, otherwise inter-VLAN communication may not always occur, or you don't want the inter-VLAN communication happen in certain situations, right? So the VLAN actually have a lot of configuration options that you may make a mistake on. So for example, the MAC address on FA01 should be in VLAN 10 instead of VLAN 1. So if you look in this example, we expect the FA01 to be in VLAN 10, but it is in VLAN 1, which is the default native VLAN. That's not good, right? So the following configuration change to FA01 to VLAN 10 verifies the change has been occurred. So now what we're going to do, we're going to go into interface configuration mode for the FA01. We're going to change it to switchboard mode access, switchboard access VLAN 10. So we are assigning VLAN 10 to it, and we're going to exit it. Now if you run show MAC address table command again, now the VLAN ID have changed from 1 to 10 right here for FA01. So that's how you're going to verify, check, and then if it is wrong, you're going to change it, the VLAN associated with that port. Verify default gateway. So that's the step 4. Misconfigured or missing default gateways can cause connectivity problems. So in the figure, for example, on the right hand side, the default gateway for R1 is 192.168.1.2, which is the R2, right? Right, yep, R2. The PC1 is 10.1.10.1, which is R1 G00. So useful commands to verify the default gateway is to run show IP route on the R1, and also on the PC we can run the route print or netstat-r on Windows machine, route print or netstat-r. Those will give you some information about that default gateway information and the routes. Troubleshoot IPv6 default gateway example. So here's an example of an IPv6 default gateway issue troubleshooting. On the left hand side, we have a example where a PC is unable to get its IPv6 configuration using Slack. Again, if you don't remember how IPv6 works or how Slack works, I have already covered those topics on my YouTube channel. Please go back to my YouTube channel and watch those videos, and you will have an idea about how that works. So the command output is missing all the IPv6 router multicast group, which is FF02::2. So if you go look at here, we have join group addresses. The FF02::2 is missing from here. So R1 is enabled as an IPv6 router, and now the output verifies that the R1 is a member of FF02::2, the all IPv6 routers multicast group. So you can see that. Why? Because now after you go IPv6 unicast-routing, it has now that command has enabled IPv6 in this router. As a result, now it was able to use Slack to obtain the FF02::2 group IP address right here, right? The multicast address right here. So that's one way that you can fix that issue. Remember, most Cisco routers do not come with the IPv6 unicast routing enabled by default. You have to run this to enable it, right? Keep that in mind. Again, if you don't remember how Slack works, how DHCP version 6 works, it's already posted on my YouTube channel. You should go back and watch those videos so you have a better idea. Also, I want to make a quick note here, just in case you are wondering, whether you have capital FF or whether you have simple FF, it doesn't really matter. It's the same address. So just so you know, just in case you're wondering, this is not a different address. It's the same address as the one we are looking for. It just one happened to be, they just type it that way. I don't know why, but it's the same thing. Step 5 in our troubleshooting process is to verify the correct path. So when troubleshooting, it is often necessary to verify the path to the destination network. The figure describes the process for both IPv4 and IPv6 routing tables, the right hand side. The process of forwarding IPv4 and IPv6 packets is based on the longest bit match or longest prefix match. Again, I have covered this extensively on my previous lectures. The routing table process will attempt to forward the packet using an entry in the routing table with the greatest number of leftmost matching bits. Again, I have covered that as well. So the number of matching bits is indicated by the prefix length of the route. Again, if you don't remember all of these concepts, go back and watch my previous videos. But on the right hand side, it is summarizing what we have covered in our previous lectures. We have the destination IP address. It's looking for a match in the route table. If there is one, which it's gonna match with the more than one entry or not. If there is not, it will be forwarding the packet, but if there is more, it will go through these processes. And same with if there is no match on the routing table, it will look for the default route, and if there is a default route, it will get forwarded, but if there is no default route, it get discarded. So this is basically how the routing works, both for IPv4 and IPv6, how the routing tables are built. Step 6, verify the transport layer. So two of the most common issues that affect transport layer connectivity include access control list configurations and network address translation configurations. So ACL and NAT configurations are common issues that might impact transport layer connectivity issues. A common tool for testing transport layer functionality is the telnet utility. So you can use this utility to test it. For example, the administrator attempts to telnet to R2 in this example using port 80, and that will give you some information on whether the connection is good or bad. In here it says the connection is bad and it has failed, right? So that's what it's showing. Step 7, you need to verify ACLs or access control lists. So on routers, there are maybe ACLs that prohibit protocols from passing through the interface in the inbound or outbound direction. So in this example, the ACL 100 has been incorrectly configured inbound on the G00 interface instead of inbound on S011. So right here, inbound common access list is not set for S011, but there is an inbound and access list is set right here on the G000. So the ACL is removed from the G00 and the configured on the inbound S011 if that's what you need in this case. So they are telling us it is incorrect, so we assume it is incorrect here. So we're gonna correct it by applying the ACL on the right interface. So configuring ACL on the wrong interface could cause problems for you as well. In step 8, we're gonna verify the DNS or domain name server. So the DNS protocol controls the DNS, a distributed database with which you can map host names to an IP address. So that's the purpose of a DNS, right? So when you configure DNS on the device, you can substitute the host name for the IP address with all IP commands such as ping or telnet in the command prompt. So if your DNS is functioning properly, you should be able to ping the name of the server or name of the device or host name, and that would be able to send the ping to that device. You don't need the IP address, because that's the whole purpose of the DNS, right? So right here we have the 172.16.1.100 with the hostname IPv4-server. But if you can ping the IPv4-server, that verifies that the DNS works. So DNS is mapping this name, the host name, to that IP address. The IP host global configuration command. So use the IP host command in the global configuration mode to enter the name to be used instead of the IPv4 address of the switch or router, as shown in the command output right here on the right hand side. You can use the ns lookup in the Windows command to display the name to IP address mapping information. So you just type ns lookup on the Windows terminal, CMD command prompt, and that would give you the name to IP address mapping information. There's a packet tracer activity called Troubleshoot Enterprise Networks. If you have access to this file through your Cisco NetAcad, please go ahead and do it right now. If you do not, I will try to find a copy of this packet tracer activity and post to my sanuja.com website so that you can learn from this particular file. And I will also, as always, try to do these packet tracer activities as well as labs on a lab demonstrations and post it to my YouTube channel later sometime. And that would bring us to the end of this lecture. And now I will go over the summary of this module as well as introduce you to a packet tracer files that will encompass some of the concepts that we have covered. So there's a packet tracer file called the network troubleshooting. If it is available to you through Cisco NetAcad, go ahead and do it. And if you don't, again, I'll find a copy of that and post it to my sanuja.com website. And same with the packet tracer file troubleshoot challenge. Use documentation to resolve issues. If you don't have access to it, I'll try to find a copy so that you can work on it, so that you can learn from those files. Here is a summary of what we have covered in this module. We learned common network documentation includes physical and logical network topologies, network device documentation, and network performance baseline documentation. The troubleshooting process should be guided by structured methods such as 7 steps troubleshooting process. For example, defining a problem, gathering information, analyzing information, eliminating possible causes, propose a hypothesis, test hypothesis, and solve the problem. So you should have a proper process in troubleshooting instead of randomly try to troubleshoot something, because that would make your life so much easier. Troubleshooting tools include NMS tools, knowledge bases, baseline tools, protocol analyzers, digital multimeters, cable testers, cable analyzers, portable network analyzers, Cisco Prime NAM, and syslog servers, and some other items that we may not have covered in this lecture. So physical layer problems causes failures and suboptimal conditions. Data link layer problems are typically caused by encapsulation errors, address mapping errors, framing errors, and STP failures or loops. While network layer problems include IPv4, IPv6 routing protocols such as EIGRP, OSPF issues. Transport layer problems can cause misconfigured NAT or ACLs. So typically are caused by those issues in NAT and ACLs being misconfigured. Application layer problems can result in unreachable or unstable resources. We also learn a bottom-up troubleshooting method can be used to solve connectivity problems. So start verifying the physical layer, check for duplex mismatches, verify addressing and default gateway, and verify the correct path is taken, and verify the transport layer. Again, however, you can mix and match the troubleshooting methodologies. You don't have to always use the bottom up. but that is the best approach. The bottom-up approach can be the best approach in most situations. If you like these type of lectures, please thumbs up this video and subscribe to my channel. If you have any questions associated with any of the topics that we have covered today, don't hesitate to reach out to me either through my sanuja.com website or by leaving a comment on one of my YouTube videos. Until next time, good luck with your exams and have a nice day.